Good morning, chemistry students, or afternoon, whatever time it might be. We're going to start into the next unit, Unit 8, which is acid-base chemistry. Now, a lot of this you've learned before, or you might be familiar with what's an acid or what's a base. So we're going to start very simple, just defining an acid or a base, and then we'll get into the pH scale and more of the calculations and numbers that classify things as an acid or a base. So to start, we have two definitions. These definitions come from Svante Arrhenius, a Swedish chemist, who's also a physicist, who did work in the mid to late 1800s. So he classified an acid as a hydrogen-containing compound that ionized to yield hydrogen in solution. So Arrhenius acids were hydrogen-containing compounds that ionized to yield hydrogens in solution. Oh, I forgot to yield. Now what does that mean? That just means it had to be something that could produce a hydrogen ion in solution. Now typically when we think of an Arrhenius acid, we always think of something that starts with the letter H, that acts as our cation, and then it's combined with some anion. Okay, and we'll see different examples as we go through. And then an Arrhenius base was a compound that ionized to yield hydroxide ions. If you're not familiar, the OH negative, that's the hydroxide ion. Okay, so really what you were looking for was the difference of a compound having a hydrogen as a cation or having a hydroxide ion as the anion. Now we say to ionize to yield, so the term ionizable is something that you need to know. Okay, so ionizable just means a hydrogen atom can form an ion. So this is just saying that it's willing to give up an electron and form a cation. Now there's many different types of acids, and we can classify them as monoprotic, diprotic, and triprotic. And this just depends on how many ionizable hydrogens are present. So if something is monoprotic, that just means one hydrogen can be removed. So if you see here in nitric acid, one of these hydrogens could be removed, and you could have the hydrogen cation and the nitrate anion. So since we just have one hydrogen, we call this a monoprotic acid. They use the term protic because the hydrogen ion can be referred to as a proton. Diprotic, as their root tells us, just means two ionizable hydrogens. So sulfuric acid, if you split apart this compound, you would have two hydrogens in the sulfate ion. And triprotic follows the pattern, means three ionizable hydrogens. So an example of this would be our phosphoric acid. So H3, so we'd have three hydrogen cations and the phosphate anion. Okay, so this is just some terms, some ways to recognize different types of acids. Now one thing that Arrhenius also discovered when they were looking at the difference between an acid or a base, well, when you have water in solution, what happens, because we know that water is polar, we can actually form what is called the hydronium ion. So this is the ion that forms when a hydrogen gains a hydrogen. Okay, so a hydrogen a water can grab a hydrogen and it can bond to one of these lone pairs, and you end up with this polyatomic hydronium ion. And in solution, when you have hydronium ions, that means you have a lot more of these acidic protons, and that indicates you have a lot lower pH. And we'll get to that kind of in the next part of this unit. Another point he made here, just talking about Arrhenius bases, this all was referring to the acid. Okay, we've seen this before, that alkali metals are very reactive in water. When we place sodium in water, we have a very violent reaction. The sodium just doesn't sit there. It releases a whole bunch of hydrogen gas in its single replacement reaction, and what you end up with is a very basic substance. You end up with sodium hydroxide solution that's left over in your beaker. And we could balance this equation first. So whenever you have an alkali metal in water, you end up with an Arrhenius base left over in solution. We know this is an Arrhenius base because we see the hydroxide ion. Now we're going to pause the video just for a second because we're going to look, I want you to watch this video comparing the relative strengths of an acid and a base reaction. So we'll come back to the other two definitions in a second.